All right, so in this section is going to be the opposite now. It's going to be what happens when the inverse is inside the parentheses and the regular sign is on the outside. So remember last time we had to do this folding stuff, but when it comes to this section, what we have to do is we're going to make triangles. So we're going to have to use triangles to figure out what the sine, cosine, and so forth respectively is going to be using not only the tangent but also its range. So let me show you what I mean by that portion. So first what we're going to do is just simplify that using what we did last section. So we know, so we have theta is equal to tan inverse of 1/2. So therefore, if we convert this, is now 1/2 is equal to tan theta, right? So if we use triangles portion, remember tangent is equal to y over x. So if we use our unit circle, so now we have 2 points, right? It's y over x. So we can have the point 2 comma 1, or we can have -2 comma -1, right? That's the other way we can get both a positive 1/2. So 2, 1 is over here, right? 2 and up 1. Or we have it down here, -2, -1 down there. So the question becomes what triangle we're going to be using. And that corresponds to now the inverse of it, right? So when it comes to the range of tangent, so tangent's range is going to be, if you guys remember, or you can just go back, it is bound between -pi/2 and +pi/2. So essentially cuts off this part here. So since this doesn't exist, that shows us what our triangle is going to be formed. It's going to be in quadrant 1 instead of in quadrant 3. So now we just cross this one out, and now we know here is our triangle, and now we go back a couple sections just to find the sine of it. So now that we know that, we know, well, x has to be +2, x, and y is 1. So now we revert it, right? We can use Pythagoras' theorem to find the hypotenuse. So 2 squared plus 1 squared is equal to r squared. This is 4 plus 1 is equal to r squared. So this is the square root of 5. So the radius is equal to the square root of 5. And then from there, now we go back to the sine function, right? So sine is equal to y over r. So sine theta is y over r, which means this is the y component, which is 1, over our radius, which is the radical 5. And there we go. So there's your hint when it comes to it is if you have the inverse on the inside, you have to use triangles to help you out. If it's on the outside, you do this folding stuff. That's the best hint I can tell you when it comes to these two because they're very similar, right, if you notice one to the other. And that's the best way, just looking at the problem, seeing where the inverse is. Is it on the inside or on the outside of the parenthesis, essentially, when it comes to it. So let's try to keep going. So all these are pretty much the exact same concept we just did for part A. So first off, we convert this. This is 1/3 is equal to sine of theta. All right, so we just make our unit circle. And now, right, we talked about this earlier. This is y over r. So we know the y component is 1, and the radius is going to be 3 itself. Okay. So since the y is positive over here and over there, correct? And again, it comes back to the inverse, the range of inverse, seeing where we're in. So again, sine inverse goes from here to here, so it means this side doesn't exist. So therefore, our triangle is going to be here. Okay. All right, so now that we have that going on, so we have r is 3, y is 1, and I just use Pythagoras theorem going backwards. Okay. So this becomes so 3 squared is equal to 1 squared plus x squared. This is 9. 1 minus 1 gives you 8. So x is radical 8. Or just use 2 radical 2 if you want. It doesn't matter. Okay. So now we have cosine. So cosine theta is x over y, or x over the x component over the radius. So our x component is radical 8 over our radius, which is 3. And there we go. That's how we get to do these problems. Okay. Pretty easy once you get the hang of it, as long as you remember when it comes to these using triangles. So it's a little bit more remembering of the stuff we did the last sections as well. Okay, so we'll just keep going with C. All right, so this is going to be negative 1/3 is equal to cosine theta. All right, so therefore we're going to unit circle. And remember, this is x over r, so x is negative. So x being negative is this side or that side, right, respectively. And cosine inverse goes from 0 to 0 to pi. So everything above it, so automatically crosses this out. And therefore, this is going to be our triangle there. So this is negative 1, this is 3. And again, just going backwards using Pythagoras there. So y is going to be the same thing, radical 8. Now, here's the problem, right? Be very careful. It's actually negative radical 8 because we're over here, right? So, well, actually, no. Positive. Yes, sorry, positive. This is positive. Real quick, I was just making sure. If, for example, right, it's down here, we get it positive, you actually want to get the negative of it. So just be wary. There'll be questions where you actually, it's a net positive. However, where the position of the triangle is, you got to make sure it's also including the sign as well. For instance, right? For instance, in this case, if we're given the y value and we solve for x, well, x is going to be positive 1 because you're taking, square root of a positive number. However, you have to remember it's actually negative because it's in the quadrant 2 portion. That's what I meant by that. Okay. And then from here we just go tangent, right? So tangent theta is y over x. So y, so y is radical 8 over x, which is negative 1, or just negative radical 8. Okay. Right. So let's keep going. So let's go D. So this one I try to trick you when it comes to it. Right. So let's see. What is cosine of 3 pi over 4? This is a trick question. Okay. So this is the opposite, right? So this is very similar to the ones we did earlier. Since cosine is on the outside, we're actually not doing triangles. We're doing this overlap stuff, right? So let's see. What is cosine of 3 pi over 4? And then just going back to our portion. So cosine of 3 pi over 4. So where's 3 pi over 4? Here it is, right here. Okay. So again, this is not in our portion, right? So there's 3 pi over 4. So we're going to do the same thing we did on the opposite end, right? So breaking this up into 3 parts. Here's that portion. Sine inverse goes from here to there. So since I'm overlapping this way, where will this end up being or go to? So what do you think? And hopefully you say overlap here. So this is pi over 4. Okay, so our answer is pi over 4. And there we go. Right. So a little trick question when it came to it because it wasn't in the domain of it. So just a quick little question. Okay. All right. So let's go to E. See if you guys are paying attention. Okay. So E says we want secant or cosecant of tan inverse of 1/2. So same process. This is 1/2 is equal to tan theta. Okay. All right. So going back to our unit circle. Right. So tangent is y over x. So we have either 2, 1, or again, negative 2, negative 1. Right? So it's either going to be here or there. Okay. Well, again, tangent corresponds to what? is between negative pi over 2 and positive. So basically the sine of it, right? So since it goes from here to here, going this way, that doesn't exist, and therefore here is our triangle right there. Okay. So now we know it's going to be that one, so it's going to be 2, 1, and we'll just go way backwards. So we did this earlier, so I'll just quickly go over it. This is going to be radius, is going to be radical 5. Okay. And now we know cosecant theta is the same thing as 1 over sine, or if you want to, radius over y in this case. Right? So therefore, it's going to be just, radical 5 over 1, or just radical 5. Okay. And then finally, let's just do the last one, f. Okay. So f is, we want secant inverse over 3. Okay. Now, this actually is a fun question. So you're not actually going to see this elsewhere, but it's just fun little one so you can see what's actually going on in these cases, okay? So this is, you can think of this as a little trick question, okay? The rest of them are going to be pretty straightforward, and that's what you want to do for these sections. This one, however, shows you where the flaw comes into play with this stuff, okay? And we'll talk about this. So there's no triangles here motionally right now, but let's see what's happening. So this is equal to theta, right? So therefore, if I convert this, this is the same thing as secant theta is equal to 2 radical 3 over 3, correct? Using the definition of secant. Okay. Now, we know that secant is equal to 1 over cosine, right? So secant theta is equal to 1 over cosine theta. So if I go opposite, cosine theta is equal to 1 over secant theta, right? Just going using relationships. So if I convert this into cosine now, all I'm doing is swapping everything around. So this is 3 over 2 radical 3 at the bottom now. Okay. Now, we actually don't even know what that is, and that's pretty much all we can talk about. So since you actually want to find theta itself, all we're really going to do is take the inverse of it. So theta is equal to cosine inverse of exactly that. It's a trick question because this is where the flaw comes into play of using triangles. But you will rarely see this, but I just want to give you as an example, sometimes, it's not completely, a primary thing you want. But, most, about 95% of the time, you're going to be using simple triangles when it comes to that, or using the folding method to help you guys out. Okay.